Hello and welcome to GeNa. In this video, I'll be showing you how to develop your own custom Spline extensions. We'll also be exploring the various event methods that GeNa's API provides while understanding how to extend GeNa's capabilities. First off, it's important to note that Spline extensions are just scriptable objects that you can attach to splines in order to perform various operations along a GeNa spline. For instance, if we create a new spline, go to GeNa, go to add spline. I'm going to create just a simple spline. You'll notice that when you attach it as a scriptable object, let's say I added the carve option, this is an operation that's being performed along the spline. Along with this, you can create your own custom scriptable objects that also perform various other types of operations along your spline. And this is another way that we can extend GeNa. You can mix and match different spline extensions to achieve various operations. For example, clearing details and clearing trees. And these operations can be performed along the same spline. There are several spline extensions that come with GeNa, but right now we're going to be focusing on making our own custom spline extension throughout the video. Without further ado, let's get started. To create your own custom spline extension script, right-click somewhere in your project, go to Create, go to Procedural Worlds, GeNa, Templates, and you'll see Spline Extension as an option. We're going to call this GeNa Gizmos Extension. The purpose of this script will be to display the height values of our terrain along the spline that we define. Now that we've created our script, let's go ahead and open it. Upon first glance, you'll notice that GeNa has conveniently set up our scriptable object with the name that we specified in Unity's project window. In order to create an instance of the scriptable object, you'll need to make note of the directory that GeNa automatically generated. In this case, it's Procedural Worlds, GeNa, Custom Extensions, GeNa Gizmos Extension. I'm going to go back to Unity and I'm going to create and attach one to our spline. So to create a scriptable object instance, right-click somewhere in your project window, go to Create, go to Procedural Worlds, GeNa, go to Custom Extensions, and you'll notice that GeNa Gizmos extension has showed up. I'm going to click on that, and now we have an instance of our script. So I'm going to go ahead and create a spline, create a few nodes in the spline, and attach this scriptable object to the spline. This extension currently isn't doing anything, but we're going to go back to the script and create some functionality for this extension. First of all, let's take a look at the execute method. This method will run every time you move or update your spline in any way. During this time, you may find it particularly useful for updating positions, for visualization, or any other kind of use cases, rather than updating it every frame. So we're going to go ahead and do this by creating a list of vector 3s, and we're going to call this points equals new list of vector 3. Make sure that you are using the system collections generic for lists. Now that we have our list of points container, we're going to go ahead and sample along the spline in execute to get the list of points that we need for our gizmos. To do this, I'm going to Before we get started, in order to sample along the spline, you'll need to start with a few variables. Float distance, we're going to start at 0. And while distance is less than the spline's length, we're going to increment distance by a spacing. We currently don't have a spacing, so I'm going to go ahead and create one at the top. Public float spacing, and I'm going to start at 0.1. Now that we have our spacing and our distance, let's go ahead and get a sample from the spline. GeNa sample equals spline dot get sample at distance and chuck in our distance variable. This will create a sample along our spline by the given distance, provided that it's below the length of the spline. If sample is not null, we're going to get the location, so now that we have our location, I'm going to add this location to our points list. And I'm also going to clear the list before we even start to generate the list. So we clear the list, we go through the distance of the spline, the entire distance of the spline. We increment the distance by the spacing, and we gather a sample at that distance of the spline. And from that sample, we're going to get the location and add it to the points array. So now this points array should be populated with a list of points every time we update the spline. Going over to our draw gizmos, this is where we're going to loop over each one of our points and update a gizmo's shape to that location. So to start, I'm going to change the color of gizmos to red. And I'm going to loop through for each var point in points. We're going to draw a wire sphere at the point with a given radius. And I'm going to create a variable for this at the top. And there we have it. So this should update our points only when we update the spline, and this will loop through all of our points and draw it into the scene view. So let's go back to Unity and let's select our spline. As you can see, the spacing must be very close. So I'm going to increase the spacing and we'll start to see all of our gizmos sampled along the spline. So the good thing about execute is that it will only sample the spline when we update the spline. So if I select the spline and move it, it will only update it at this point in time. Before we move on, I'm going to change the name of our spline to gizmos. And now the whole game object's name is spline gizmos. There's a slight issue that we have with our spacing where if it goes below 0, this could end up being an infinite loop. So what I'm going to do is I'm going to make sure that we always get a max value between spacing and 0.1. So if spacing goes below 0, it will default to 0.1. And that should stop us from getting into an infinite loop. So let's scroll down. You see on activate and on deactivate. So what on activate and deactivate do is every time you click on this tick box here next to the extension, it will call the on activate. If you untick it, it'll call the deactivate, which is useful in some cases if you want to extend GeNa. I'm going to demonstrate this by using the debug log though. So I'm going to create a debug log and I'm going to call this name, which is the script name, has been activated on spline.name, which is the name we just changed it to. So it should print out the gizmos extension has been activated on the spline gizmos. And I'm going to do the same thing, but for on deactivate. So let's go back to Unity, go over to our console and select deactivated. So you can see we've got our console log that just printed out here. I'm going to reactivate it again and we should see the other one. So you can perform any sort of operations at that point in time as well. There's also another event called onAttach. OnAttach is when you click and drag the extension onto the spline itself. So I'm going to use the same debug log, but I'm going to change the wording a little bit. So it has been attached to spline name. And we're going to go back to Unity. I'm going to go to my project folder and I'm going to click and drag another instance onto it and go back to the console, and you'll see we've got gizmos extension has been attached to spline gizmos. So you can perform an action on that instance as well. There's also on select and on deselect. So on select allows you to perform an event when the extension has been selected in the editor. So this extension has been selected on spline name, and the spline has been deselected on spline name. So let's go back to Unity. So you'll notice that I've got two of the extensions selected, so I can switch between them and it will perform a select and a deselect event. So it's deselected the other one and selected the new one. Now to further test this properly, I'm going to switch the extension over to details. So I've got one of them as details and the other one is Gizmo's extension. So I'm going to clear that. I'm going to select the on Gizmo's extension and you can see this one has been selected. If you click away from it, it has been deselected. So this is another action that you can perform an event with. So going back to the script, on delete gets called just before the object gets destroyed. So if we were to perform a log here, the scriptable object has been destroyed on spline this one. So we're going to go back to Unity and I'm going to remove this extension from the spline and you'll get a message saying that it has been destroyed on the spline. So if you need to do any cleanup, any memory cleanup, you can do it there. So now we have another event that you can override, which is an editor-only event on scene GUI, which gets called during editor events, and you can perform editor handles and other kinds of editor scene events in the extension itself. To do this, you can go up to the top of the script, you can go using Unity Editor, which by the way is very safe if you do the #if Unity Editor preprocessor directive, followed by an endif. So if we're in the editor, we're going to use the editor namespace. And going back down to on scene GUI, we're going to do the same thing, #if Unity Editor, and if we're going to perform our editor functionality here. In this function, we're going to use our points list that we generated earlier to create a series of labels and visuals in order to detect the heights on our terrain. So to start, I'm going to set my handles color to red. I'm going to loop over for each point in my points list. We're going to basically create a handles sphere handle cap. The control ID will be 0. The position will be point. The rotation, there's no rotation, so I'm going to do identity, quaternion.identity. And then I'm going to set the size to 0.5 to start with. And we're going to set the event type to repaint. This will draw a sphere at that point. And I'm also going to turn off the gizmos for now by commenting out these sections. And I'm going to go back to Unity. As you can see, we have a series of handle points that are drawing along our spline. We can change the spacing between them, but we can't change the radius just yet. And at the moment, it's not actually sticking to the terrain. So I'm going to show you how we're going to fix this. The best way to do this is by going back to our script. Let's go all the way up to where we did the execute method. And we're going to grab the location. We're going to get the active terrain by going terrain.activeTerrain. If the terrain is not null, then we're going to perform the following. We're going to get the location, its y coordinate, and we're going to sample the height above the terrain at the location. And now that we have our sample height, this should update the location before it gets put into the points array. So if we save this, go back to Unity, you can see that our handles are actually conforming to the terrain heights. So if we move this around, it'll update the heights along the terrain. These spheres are a little bit tiny, but I'm going to create an arrow to point at the sphere so that we can see exactly where it is from a distance. So let's go back to our script, scroll all the way down to the on-scene GUI. And what we're going to do is we're going to create a handles arrow handle cap. We're going to set the control ID to 0. The position is going to be point. The rotation is going to be quaternion.look rotation, vector3.down. So point down. We're going to set the arrow's size to about 2. And we're going to set the event type to repaint as well. So let's see what this does. If we go back to Unity. So this creates an arrow that points in the direction of where the ground is. But it's actually starting from the top and going down. So I'm going to offset the position by a certain amount. So plus new vector3, 0 on the X. And on the Y, we're going to put 2.5 units. And go back to Unity. And there we have it. But I'm going to change the color of the arrows. So I'm going to move this handle's color down to where sphere handle cap is. So it'll change the sphere to red. And I'm going to set this color to handles.y-axis color, which is like a green color. There we go. So we've got a green arrow pointing down to where the height is. So if I move this along my terrain, you can see it's updating the heights. And we can see it a bit better. You can increase the spacing, you can decrease the spacing. And there we go. Next, I'm going to create a label that sits above each one of the arrows to tell me what number the height is at the moment in world units. So let's go back to Unity. And just above the for loop, I'm going to create a GUI style. I'm going to call it label style. It's going to be new GUI style, GUI.skin.label. So I'm going to grab Unity's label skin as a default. I'm going to set the label style's normal state text color to white. I'm also going to set the label style's alignment to middle center. So text anchor middle center. And I'm going to set the content offset to new vector2 0, and I'm going to bring it up 50 pixels. So now that we have our style, we're going to use the handles label option down the bottom here. I'm going to go handles.label point. So it's going to be at the position, and I'm going to make the text look like this. Point.y colon 0.0. This means that it will format it to 0.0 format. And I'm also going to apply the label style. There we go. So this should create a label just above the height. Let's go back to Unity. And you can see that we have our labels directly above the arrows. So if I increase the spacing and move it around, you can see that it updates with the height value. So we can be absolutely specific to what we want with the heights. Now I'm going to improve this a little bit by adding a few more variables here, and I'll show you how to go through and make your own custom editor with GeNa's extensions. So let's go back to our script, and I'm going to simplify this a little bit by making a variable for the size of the arrow as well as the sphere radius for the handles. So let's go up the top. So let's create a float called dot size. I'm going to set that to 0.5. We're also going to create another variable called arrow size, and that's going to be set to 2 by default. Let's scroll back down. So where we've got the arrow handle cap, I'm going to go arrow size. We also want to modify the offset dynamically whenever we change the arrow size. So I'm going to use the following formula. I'm going to use arrow size plus, in brackets, plus 20% of the actual arrow size so that the pivot point gets offset. Then we're going to change the sphere's size to dot size. So now we have variables for both of these. Let's test it out. So it's a little bit smaller. So if we change the arrow size, you'll notice that the pivot of the arrow is shifted over down to the center. So we can change the size of the arrow, and the dot size can also change. And if we also change the order of these handle renders, they will draw on top of each other. So I want the sphere to draw underneath the arrow handle, and I'm going to leave the handle label here so it draws on top of everything else. So go back to Unity. You can see that the arrow is drawing on top of the sphere. So wherever we look at it, it will always be on top. I'm also going to create a toggle that lets us switch between the gizmos version and the handles version. So let's go over to our script. I'm going to create two bools, one at the top called public bool draw gizmos, and I'm going to set that to true by default. I'm also going to do public bool draw handles. I'm going to set that also to true by default. So if we scroll down to where the draw gizmos is, I'm going to uncomment this code that I commented earlier. And I'm going to write down if draw gizmos is equal to false, we're going to return. So if it's set to true, it's going to draw this. If not, it's going to exit the function. Same thing for the on-scene GUI. I'm going to go if draw handles is equal to false, we're going to return. We're going to exit the function. So let's save that, go back to Unity. Now we have these two toggles. So if we want to turn off gizmos, we can. And if we want to turn off handles, we can also do that too. And lastly, if you wish to extend your scriptable objects editor within the GeNa Splines panel, you can make your own custom editor for it, and GeNa will automatically pick up the formatting. So to do this, we're going to create a folder inside of our scripts called editor. And we're going to create a new script in that editor folder called GeNa Gizmos Extension Editor. And let's open it up. So we're going to use this as an editor script by using Unity Editor at the top. We're going to get rid of the start and update functions. And we're going to add the custom editor attribute to the top. And it's going to be a custom editor of type of GeNa Gizmos Extension. Now, instead of inheriting from the editor class, we're going to be inheriting from GeNa Spline Extension Editor. And this will allow GeNa to render the editor within the spline itself in the extension panel. So to do this, I'm also going to get rid of the system collections generic as well. And what I'm going to do is I'm going to create a variable for GeNa Gizmos Extension. We're going to call this Gizmos Extension. I'm going to have an onEnable method. And in this method, I'm going to assign Gizmos Extension to target as GeNa Gizmos Extension. And then I'm going to override the onInspector GUI method. And now that we have our custom editor GUI layouts, we're going to go back to Unity and check out our spline. And now you can see it's using our custom editor. And that's how you create your own custom extensions in GeNa. Thanks for watching.